talking about the technical challenges of serving docs at Google's. So that'll be fun.
Let's see. All right, good afternoon, everyone. My name is Ashleigh Rentz. I am a program manager at Google working in developer programs. My role there is one of obliterating chaos. I don't know that you can read that on there, but my business card says de-chaosifier. That's what I do. I started at Google back in 2004, working in the data center as a hardware technician, and we were just starting to grow really fast back then. So we were always needing more hardware, kept me employed, and I started teaching Linux to our new hires. From there, I started doing education classes within the company, and then in 2010, I got involved with the team of tech writers who develop API documentation for us. Today, I would like to tell you the story of how our CMS, our content management system, came to be. If you will humor me, I would like to take you back in time. But before we can go back in time, there is a big, looming question I have to answer. Why am I going to stand in front of you for 39 minutes and talk about this? Well, in 2005, when we first started setting up this website that was hosting API documentation, Google was a much smaller company. We only had about 10 developer products at the time. I think the AdWords API was the only really significant one. But if you skip ahead just 6 years, which isn't that long, we had so many developer products that Ernest Delgado, who's also on the developer programs team, or used to be with me, he literally filled up a periodic table with all of our developer products. Now, for every one of these, every product needs developer documentation, right? And you have to have somewhere to put it. And this brings me to the key point of our talk. With that much documentation, if you don't think carefully, scaling problems can show up so gradually that you barely notice them until you're in big trouble. And in 2011, we were in big trouble behind the scenes. We got there through a combination of things that started in 2005. And in 2005-2006, when our original CMS was developed, those decisions made perfect sense. Everything was great back then. But the assumptions that were made then turned out to not be correct for what we eventually used the system for. We didn't notice that, and we didn't notice it until 2010 when we started getting in trouble. And then by 2011, things were falling apart at the seams. We had to do something. We had to act then, and it was very painful. So I hope that by listening to our story, you can get some ideas about how your own content management system is handled, so that if you are so fortunate as to experience the kind of explosive growth that we did, and that's what all of you hope for, right? That you'll be able to, even if you don't have time to set up something robust to start with, you have to ship, right? But if your underlying assumptions are correct, you won't suffer the same hardships we did. So with that, let's go back in time, 2005. You guys know about Slashdot, right? Big news site in the early 2000s, and we just hired Chris DeBono from over there. We put him in charge of open source at Google. That's kind of a nebulous thing to say, be in charge of open source. So one of the things that he's been working on over the years is making sure that we're compliant with open source licenses. Very important. But another thing that he was working on in 2005 was getting Google to contribute back to the open source community. We had gotten a lot from them. We were able to use Linux to build our servers and what have you, to build our search engine. We wanted to give back. So to do that, we picked some projects inside the company that we wanted to share, and we needed a place to put them. We developed a website for that, code.google.com, a place for us to share code. Internally, we refer to it as Code Site, and I'm going to call it that today, if you don't mind, because it's a lot easier to say in conversation. And in 2005, when we launched Code Site, it was just that. It was an introductory place to put some code, to talk about what it was going to do, to give people an archive to download. Now, the 10 or so API products that we had at the time, we needed a place to put docs for them. And if this was going to be Google's website directed to developers, then that's the sensible place to put it, even though those aren't open source products. CodeSite was built using EasyT, or easy templating for Python. It was developed by Greg Stein, who is well known in open source circles. He was working for us at the time. EasyT is great. It's a very simple markup language that you can use to define some build logic in your documentation. So in this example code, what I've done is we have a piece of boilerplate here, and that boilerplate would have gone in every single one of our pages of documentation. And by using two include statements, we can put a lot of the logic that's common into two files and just bring them in very easily. So every page needs a header, it needs the meta tags, it needs the header, and by defining a variable on the first line, we can put the logic for that in one unit. Likewise, we can include a page or include a file called page header. That would contain things like the site logo, the search bar, and if we want to add things to it later on, like a login link, the code is all in one place. It's easy to do. We had a cron job that would run every hour or so, and it would take all of these files, and it would follow the logic in them to build the website and push it out. Now, back then, 1 gigabyte was massive. We had just launched Gmail a year ago. I don't know if you can read the text on the t-shirt, but it says, "Google gave me a gig, April 1st, 2004. Web resources, and back then, a gig was massive. What was the standard? About 10 megabytes or so? Yeah. So we were really churning through the computing resources. And working in the data center, we were buying computers like crazy. We were building them as fast as we could, but we couldn't keep up with what the engineers were doing. So eventually, engineering leadership in the company said, we have to put the brakes on this consumption. We're using stuff too fast. You have all these computers where you've filled up the hard drives, but the CPU is sitting there idle. And you have this cluster of computers that has perfectly free network bandwidth, but this cluster over here is completely clogged up. You guys have to do something more efficient. And that played a role in how CodeSite was designed. It was set up to cache as much as it could in memory. It was optimized for small files, about 256K. Ought to be enough for anyone, right? So it would cache things in memory. It would try to minimize disk I/O. And it was very good at serving small web pages really fast. As the site grew, however, some of the assumptions that I'm leading up to have changed. In 2006, however, the open source team launched project hosting on Google Code. Now, project hosting actually uses a separate backend than the static content server I was just showing you. And this gave the open source team a great place to put their projects. It's a repository for open source projects. In 2006, we didn't have GitHub, of course. So it was kind of like SourceForge, but with some differences. And the open source team started moving their code samples over there. And each project had a wiki, so you could put the docs right next to it. It was really great for their needs. But for the tech writers that were documenting APIs, it didn't suit them so well. So the CodeSite static that I showed you earlier in 2006, it started becoming dedicated to API documentation. That was a change in the fundamental assumptions behind this site, however. And when I joined the team in 2010, we had started to see that explosive growth that led up to the periodic table. At that point, we were starting to have a lot of problem. Our builds were starting to give these failure errors pretty often. It was a big problem for us because when the build failed, none of the new docs could go live. Let's look again at the EasyT file that I showed you earlier, except this one is a little bit different. I added a typo. Now, some programming languages, if you make a typo or you do something a little non-standard, they're going to try to figure out what you mean. HTML itself is a great example of this. If you do something wrong, it tries to divine your meaning, and it tries to do the right thing, but that can have unexpected results sometimes. Well, we don't want that for documentation that we're building on the site. we want to be notified that there's a syntax error. So our EZT parser, it would play dumb. It would say, I don't know what this is, help, help. And we would have to go in and fix the error. Now that's fine ordinarily, but because of the explosive growth, we were starting to see files take much longer to build. And by 2010, the build was routinely taking about 45 minutes. So let's put yourselves in the shoes of one of our tech writers back at that time. Let's say that you have an engineering team that wants to launch their new product at 2 p.m. So a little before 1 p.m., you check the documentation into version control. At 1 p.m., our cron job starts. It kicks off a build process, and then the cron job goes to sleep. 45 minutes later, it wakes up, and it checks the state of that build. But here's the thing. You made a typo. I'm sorry. The build failed at 2:45. So really fast, you jump in. You go find the mistake. You get it fixed. You check it into version control. And another build starts at 3 p.m. and you go tell the engineering team how sorry you are. Unfortunately, while you were doing that, another tech writer was working on another product and introduced another typo. So now, at 2:45, you get another error. And you have 15 minutes before the next build starts to go find where the error is, to go fix it, to get it in time for this 3 p.m. build so that you can go tell the engineers, maybe 4 o'clock, fingers crossed. The engineers are just beside themselves. They can't believe you. The PR team is losing their hair because the online news sites are starting to run this story about this product that they've got the scoop on. Nobody is happy, and it's only getting worse. And here's the worst thing. EZT, it uses square brackets, which is fine for a lot of things, but we've started using it for developer documentation. We tend to use square brackets a lot when we're talking about code samples. This is some perfectly legitimate HTML. You have a very simple sample code that uses a list in Python. Other languages use square brackets in very similar ways. This is completely valid HTML, but when you give it to EZT, it looks at that and it says, user 1, user 2, user 3 is not a valid EZT tag. I don't know what to do with this. I'm going away for the next hour. So if you needed to use square brackets, which we did quite frequently, you had to use square brackets to escape your square bracket. We must go deeper. The EZT engine, our parser, was pretty happy with this. It understood what it was supposed to do now. It's saying, oh, you want a literal square bracket. But this makes no sense to humans. And how often are you really going to remember to do that? Are you going to remember that every time you use a square bracket in your API documentation? So that was the #1 cause of build failures, typos and misplaced square brackets. And it was becoming a very fragile system as we got more and more people using it. And when one tech writer made a mistake, it influenced the workflow of all the tech writers. Now, we had other failures too. Some of them were outside of the writer's control. The biggest prime example is disk input and output. Sometimes in the data center, the disk were just doing slow I/O. Maybe the hard drives in the machine were failing. Someone needed to swap them out. Maybe we just had too many different programs running on the single server. The cron job was not very smart, though. It went to sleep 45 minutes. It woke up. It checked the state of the build. If the build was successful, it said, hooray, I'll put everything on the web. But if the build wasn't successful, including if the build was still running, it was considered a failure. The cron job aborted what it was doing, and we were stuck. This was becoming a huge problem for us because back in 2005, when the website was set up, we only had a handful, maybe a few hundred files on it. We could easily do the whole build process in 10 or 15 minutes. Not a big deal. But by now, we were pushing the hour boundary for how long it would take to do a build. And we were getting very, very close. The gap between when one build finished and the next started was shrinking dramatically. Now, if we're already seeing some failures from bad disk I/O speeds, imagine what happens if the builds start to overlap. So at this point, we had to make the difficult decision to spread out these cron jobs even further and to only run them every 2 hours. But if you're a tech writer and you need to put something on the internet, you have to do it at least 2 hours beforehand if you're lucky. Now let's say that you've accidentally made a mistake. It happens to all of us. I've done this. I've accidentally published something that wasn't meant for the public. Oh, I've done that. And you need to take it down as soon as you can. So I would be having PR people talk to me and tech writers come up to me and say, please, Ashleigh, please help. And I would immediately start this whole process to help them take it down, but it would take a minimum of 2 hours. And that was assuming nothing bad happened like we were just talking about. This is not good for tech writers. You just want to write the docs and put them on the internet. Is that so hard? It shouldn't be. Eventually, though, we would get success. We'd all take a deep breath, exhale. All is good in the world. I have written the docs. They are online. What could be bad? Well, if you're writing API documentation, there are other things that can happen. You probably want to put a demo on your documentation. You're telling people, use this awesome API we developed. It can do cool stuff. Look, here it is, see? This is not an especially great demo. It draws a heart on the screen, but it's a very vulnerable heart because tech writers, let's you and me be really, really honest with each other right now. When you go and write programming code, you aren't writing for scalability. You're not writing for security, and you're not writing for stability. What you are writing for is clarity. You're writing for human comprehension, and that's the right thing to do. Unfortunately, it has a side effect. When your code is simple, sometimes you leave out things like sanitizing JavaScript input, and we get these horrible cross-site scripting vulnerabilities, XSS. These are really bad. This means that somebody, some malicious person out there has figured out that if they format a URL just right, your code will run what they want it to, not what you want it to. And even worse than that, it's going to run on your domain. And in our case, that's google.com, which meant that these malicious people could do things as logged-in users and really mess up their accounts. This is bad. I would get these bug reports about these, and we would immediately just ship them to the tech writer that came up with it. We need a fix urgently. Get me a fix for this. They would drop what they were doing, go look at this code that they wrote 4 or 5 months ago, talk to an engineer, get it fixed. We'd put it on the website, but we were seeing enough of them that we at any given time, we probably had a vulnerability somewhere. And writing perfect code is not really a strategy. Being perfect is it's not going to get you very far. So I'm going to come back to that in a little bit. But first, it was 2011, and we were getting ready for Google I/O. It's our big developer conference that we hold every year. On more than that, though, it's also our biggest press event of the year. We do a lot of new product launches, and this was my first year working in the production room there. I was handling the code site builds. I was scrutinizing every single piece of technical writing that was going out to make sure that it was syntactically correct and that it wouldn't cause those build failures. But there were still enough things outside of our control that we were using hope as our strategy. We got lucky in 2011. We only had one build failure, and it only happened when we were launching a minor doc set. But when you're launching docs, when you're launching developer products, you have to have docs with them. Now, you don't want to put the docs online too early, because then people will find them, steal the thunder from your presentation. So you want the docs to be online, but not too early. But here's the thing. Everybody, look up a moment. Look at how many open laptops are in this room. If I were launching an awesome new product and I put a URL on that screen, raise your hand if you would immediately start loading that URL. I see a lot of hands. And if you got a 404 error, what would you think of me then? You would think I was lying about my awesome product. So to time this correctly, it was a lot like standing on top of a bridge and trying to jump onto a moving automobile. You had to time it just right, and if you didn't get it right, there was going to be a catastrophe. Of course, we were having to jump about 2 hours before we could even see the car. This is not something we wanted to do in 2012. When you have a vice president and a co-founder of your company on the stage talking about how awesome your products are, you really want to have confidence in your documentation CMS. So using my grand artistic ability, we had two choices. We could slap some Band-Aids on this thing and try to make it better, or that's a big red reset button we could push, and we could design a new CMS. The Band-Aids that we had, we evaluated them. Well, the cron job could have been a lot smarter. It could have checked a lot more frequently for those build failures instead of just waiting 45 minutes. The build could have failed in the first minute it was running, or in the 30th. The sooner we get the error, the better. But that wasn't going to make the successful builds go faster. And there was some programming logic we could have improved with the EZT parser to speed that up, but it was only going to help so much, and we had every indication that the site was going to continue growing. With over 100 developer products at the time, and with the docs for all of those on this site, and with translations for many of them into about 8 core languages that we were dealing with, we had gotten up to about 60 to 80,000 files at this point. So we decided instead we needed to revisit the situation, develop a CMS that was actually meant for developer documentation. Now, the open source team I told you about, they had moved on. They were working on the project hosting system. Code site static had been pretty much left to the tech writers to run, and they were struggling a lot with it. We had 2 of them who were doing engineering work in their copious spare time in addition to writing the docs. One of them is Dan Sanderson. He also wrote the O'Reilly book on programming App Engine. And he had a lot of great ideas for a new CMS. He really understood why the writers were suffering. Nils Tikkanen was also on our team. He had been writing for the AdWords API and helping out with the site. So in 2011, the 2 of them became full-time engineers and stopped doing technical writing. And we put together a team of people to work on this new website and this new CMS we were going to put together. That website is developers.google.com. Much like we call code.google.com code site, we call this dev site. It's a lot easier to say when you're repeating it over and over. Dev site was built differently. In 2005, when code site was built, they had to do everything pretty much manually inside Google's custom infrastructure, and that can be complicated. But we had a big advantage they didn't have. Because we had come up with so many developer products over the last 6 years, we had App Engine. We were able to use the same thing we tell third parties they should use. Now, if any of you aren't familiar with App Engine, it's a platform as a service. You just go write your web app in Python or in Java, and you upload it to this. You don't worry about operating systems. You don't worry about servers. If your website starts getting hammered to death with more traffic than you can handle, App Engine is an engine. It spins up, it starts running more servers, it handles that load for you. It's really robust, it's worked incredibly well for us. Now to get this running up and fast, developing new software, we wanted to use an existing framework and not try to invent everything from scratch. We really like Django for this purpose. Django is a framework for developing web apps. You can use Python with it. And there's a problem, though. Django depends on a relational database. App App Engine does not provide one of those. It uses a non-relational data store. I'm afraid I don't have time to go all computer science college classes and explain relational and non-relational databases, but we needed something on the back end that could speak both languages and make these two technologies work with one another. We found a great open source project, Django Non-Rel, non-relational. It sits on the back end and it can speak both languages. It enabled us to use the awesome Django framework on top of what we think is an awesome App Engine. The way our server works, an HTTP request comes from the browser, App Engine catches it, sends it off to some back-end server that we never talk to, and it starts running our web app, which is composed of a Django view. It looks at the URL, it inspects the path name, and it decides what handler, what program it needs to run to respond to it. The handler then looks for a template. Now, most pages on your website share a lot of common elements. You don't want to duplicate them, so you have a template which says, this is the basic format of the page, plug in your data. And then we have data in the App Engine data store, and that data is what our tech writers produce. Now, after 6 years of using EZT, our tech writers had gotten used to being able to use variables in their documentation and be able to use some logic. So we took the Django syntax, and there's an open source technology that helped us do this. I am blanking on the name of it, I'm sorry, but it's out there if any of you are interested in something similar. And we were able to use Django syntax in our HTML. So this is not strictly HTML. If you look at the first line, it says HTML dev site. This is special for us. But it's pretty much HTML with some logic tags thrown in. Let's say that price is a variable. And the price of an API, it changes over time. You don't want to list it out by hand in 10 different places and miss an update when it changes. So we can test if the variable is defined, and if it is, we can interpret it into the page. If it's not, we can print something else entirely. We then use a custom publishing script, which evaluates these Django syntax tags and determines what the page is supposed to look like. Now, this is all static. This gets done at the time that an author wants to publish their documentation. It does not change until the writer comes back to it again. This is what we put in App Engine in the data store. And then we have Django templates that look something like this. They show the site logo, the search bar, all of that logic. And then there's an empty block where the Django handler knows, oh, I need to plug in my data here. So the template gets rendered, and if the price variable is defined, you end up with a result like this. And this is what Django gives back to App Engine to give back to the user. Works really well for us. We really like Django syntax. The tokens that it uses are 2 characters, and those are not characters that you're very likely to see in the kind of documentation that we produce. I can't think of any programming languages that use curly brace % very often. But after our experiences with EZT, we're very wary of that kind of thing. So what happens if an author does need to use something like this and forgets to escape it? Well, on CodeSite, that would break the workflow for everyone. But that's the first big departure in this CMS. There is no site-wide build anymore. Instead, we build only what a writer asks for, and only when it's asked for. Now, this has a couple of benefits. The biggest one is that instead of taking 45 minutes or an hour to find out if you have a syntax error, you're typically working in a directory by yourself, and you're not building the whole site, so you're dealing with a few thousand files at worst instead of 80,000, and you're going to find your syntax error within 60 seconds instead of 60 minutes. And also, because you are working in an isolated directory, if another writer is working in a different directory on their docs, they don't care about your errors. They aren't in the way. They can go ahead and publish their stuff, and vice versa. You don't have to worry about that new person that started that doesn't seem to know what they're doing. You can publish their docs, and then please go help them out. They need it. There is a trade-off, however. Remember that price variable we just used as an example? Well, suppose that a lot of your APIs use the same pricing information. You can keep that variable in one place so that it applies to all of the documentation. But because we don't build the whole site anymore, if a variable that you depend on is outside of your documentation, when that variable changes, you have to go republish your docs because we only build what the writer asked for when the writer asked for it. We currently have someone who is working on a script that can figure out what these variable dependencies are and track them and create a notification when they do change. We don't have that yet. It is a trade-off, but this is still a lot less painful for us. Let's get back to cross-site scripting vulnerabilities. Now, earlier we were looking at that hack that had access to the google.com cookie, and we said, hope is not a strategy. Trying to be perfect is not going to work. If you rely on being perfect, you will always be imperfect. So what we realized, we don't want to teach people to write vulnerable code. So we still tried to keep these vulnerabilities out, but we gave up on the idea of being perfect. And instead, using our Django syntax in the docs that our writers produce, we created this custom framebox tag. What happens with this is if you're going to do something using JavaScript that could potentially have a vulnerability in it, you wrap it up in a framebox. And when we run our publish script, it sees that, and it extracts everything in the framebox, puts it in a separate file, uploads it to a separate server, which is on a separate domain. It then uses an HTML inline frame and iframe to replace that in the page so that it looks like your demo is part of this page, but if you have a vulnerability in it, somebody who is malicious can still try to exploit it, but without access to your google.com cookie, it's not going to get them very far. It's not going to be very damaging. So it's a damage control measure, and it's worked pretty well for us. In late 2011, we had enough features completed on the new site that we could start the process of migrating things from the old site to the new site. But when you have over 100 developer products, it's going to take some time. We had 80,000 files telling everybody in the company, all right, nobody touches CodeSite for the next 6 months. No, the tech writers were not going to allow that, neither were the engineers. They would have said, you're ludicrous, figure something else out. So what we started with was a script that could recognize common boilerplate that we used in the EZT files. It would identify that boilerplate, and it would understand how to translate that into our Django syntax that we're using on the new site. Now, it wouldn't recognize all EZT, because over 6 or 7 years, authors have done a lot of things that we never imagined they would. That's what happens when you give them a templating language that has some logic to it. That's good, though. They produced some novel things. So in the lead up to this migration, what we did was we said, tech writers, take this script, run it against your docs, and just see if it works. If it doesn't, most of your EZT template tags, most of those can be changed so that they will work with the tool, and they can be changed without doing anything that would be user visible. So for a while, we were using this tool just to get the docs into a state of readiness for the migration. At the same time, writers were continuing to iterate on the docs and document their new features of the APIs. After that, we would finally get to a point where my team had resources to stop and help, and the tech writers were ready to stop work for a few days, and we'd say, all right, we're ready to move this one set of documentation, this one directory. We would stop work on it, we would use the script to create the new files, we'd copy them over, and on CodeSite, we would set up a redirect. That way, any old links would continue to work, they would just take you to the doc's new location. Unfortunately, this left us in a bad state where we had docs on 2 different websites for developers. It's an awkward time for users. they think, well, I need to find developer documentation, but I don't know which site to go to. The redirects were one thing we did to try to minimize that pain. The other thing was that we made sure that the search boxes on both websites would return results from both websites. We wanted as much as possible for the users to not need to know where docs were. It was still an awkward transition phase, though, and our biggest goal was to finish this migration before May 2012, when we were going to have Google I/O again, partly because I didn't want to be in the production room sweating bullets with people on stage, partly because we wanted a single documentation experience for our users. So this tiny, tiny blip on the timeline represented a huge amount of work. And I led that project, and I have enough war stories about it that I could easily fill up another 40-minute talk. I'd call it the organizational challenges of migrating docs at Google scale. But this is a technical talk, so we'll stick with that. And we got everything onto Deb's site. Everything's been working really well for us. I/O 2012 came and went. We didn't have problems. So to sum this up, I'd like to get back to the question I started with. Why did I just tell you that story? Remember, in 2005, Google was a much smaller company. We'd just launched Gmail. Google Calendar didn't exist yet. Never mind Google Apps, never mind App Engine, never mind all these things. But because our growth was so explosive, our documentation strategy was still stuck years ago when it had been planned to do something else, when it had been planned to just show some small information about open source projects and send people to go download the code. Scaling problems can and do show up so gradually that we barely noticed them until we were already in big trouble in 2010. If, when we had started this documentation project, if back in 2006, when open source moved to project hosting, we had thought, does this system make sense for hosting API docs? It would have been a lot easier to change gears back then. But because we accumulated all this documentation and technical debt over the years, this became a humongous project for a team of about 7 or 8 people to handle, in addition to involving well over 100 different technical writers and engineers throughout the organization. Being a program manager, that's the kind of project you love and you hate at the same time. But we were lucky. Being Google, we had a lot of resources at our disposal and a lot of people that were ready to pitch in and help. At a smaller company without those resources, I understand. You have to get something shipped, you have to do it yesterday. But just think really carefully about those underlying assumptions. Because if you get those right, then you'll have the opportunity later to build something that is robust when you need it. But if you get that wrong, you may not get a second chance. We were lucky too. That's all I have for you. Thank you so much. Thank you. All right, so I would actually like to not do a traditional Q&A on stage. Instead, what I'd like to do is something more conversational. I'm going to step out into the hallway. If you have some questions for me, I'd love to discuss those as a group. We also have another talk starting in just a moment. I don't want anyone to feel like you need to miss that. So I'll be here throughout the rest of the day, and I'm very easy to spot. Please walk up to me. I'd love to talk to you about anything to do with documentation. Thanks so much, everyone.
And thank you.